Okay, grade 11 pre-cal, lesson 11, the sine law, or the law of sine, sometimes referred to it. So in the past, you've done trigonometry, otherwise like the SOHCAHTOA. All the triangles have been right-angled triangles. Well, in the real world, there's a lot of triangles that are not right-angled triangles. So we have this law that allows us to do trigonometry without right-angled triangles. It's called the law of sines. So if you look here, here's your standard triangle. Capital letters are usually signify angles. The smaller letters usually signify sides. And if you look, we got capital A, little a across from it, capital C, capital B, little b. So based on that, we have our law of sines. So A over the sine of A, right? The side over the sine of the angle, B over sine of B, C over sine of C. Sometimes you'll see it written completely upside down, where the sine capital A is on the top and the little a is on the bottom. Either way it works, as long as the pattern is followed. Okay, so here we go. Let's look at our first triangle here. And we're not always going to use like A, B, and C. In this case, you can see we're just using A and C. So here's our triangle. Big C, 105. Little c, 21.5. Big A, 58. And we're looking for little a. We're looking for a side. So we just set up the formula. A over the sine of A equals C over the sine of C. In this case, we couldn't care less about B, right? We don't need it at all. Now, if we ever needed to find angle B, well, look, 105 and 58, we know all three angles of a triangle equal 180. We could subtract that and get angle B. But we don't need it in this case because we're not looking for it. So then you just plug in everything. So A over the sine of 58 equals 215 over the sine of 105. Bang, cross multiply. Make sure your calculator is in degrees. We'll go to 1 decimal place. So A is 188.8, right? That works out. So that's really easy, right? You can do that. You just cross multiply. Now that's if you're looking for a side. What if you would need to look for an angle? So we got another triangle here. A, B, and C, right? 54 is big B, so the little b or side B is 3.45. Big A is over here, little a is 3.60. So in this case, we're looking for angle A. So we set it up, and if you look, hey, look, I set it up completely upside down just to show you that it still works, right? You could have done it A over the sine of A equals B over the sine of B. I did it upside down, big deal, right? Just like here. See how I did it backwards, this one? Okay, fill in what you know, bang, bang, bang. So sine of 54, 3.45, 3.60. Cross multiply. And when you do the math, you realize, what the heck? I get this as an angle? That doesn't make any sense. We got to remember one thing from previously. If you're looking for an angle, you have to do one more step. You have to do the inverse of it, right? So use the inverse to find the angle. So in this case, angle A, take the inverse sine of that number, and you end up with, we round to nearest degree, 58 degrees, right? So the last step there, it works. The math is the same. It's still cross multiply. The only difference is when you're looking for an angle, you have to do the inverse at the end. Okay. Next page, let's look at example 3. Now in this example, you're given just a bunch of numbers. You don't get any triangle. So if you need to, draw the triangle. So B, A, and B. So they give you side B. So you can draw it however you want, A, B, C. Right, little c, big A, big B, little b. Now let's fill in what we know. Little b is 51.6. Angle A is 67, angle B is 70 degrees. So we need to find side A. So look, yep, we're looking for a side across from an angle, and we also have a side across from an angle. So in this case, we don't even need C in the equation. So again, A over sine of A equals B over sine of B. Fill in your numbers, right? There they are there, bang, bang, and we're gonna cross multiply. And then we end up with an answer. And if you notice, there's no units here, right? Because they didn't give us, we could actually put the word units if we needed to. Okay, last example. Now this is kind of a neat one. So another option, and you did this in the past, another option is to take a triangle, right, and break it up into right angle triangles. So that goes back to the SOHCAHTOA stuff. So for instance, you have rabbits at X, Y, and Z, right? And we want to find the distance from X to Z, or little y is what we're doing. So we could technically break this up into the middle here, right? Calculate like the height on this one, right? And then use the, we have 40 and 75, so we could figure out the 65 here, right? Use that H and this angle to find this guy, and then you could add it all up. Now, also, you could have done this completely different and just use the law of sines, right? So if you look, 75, 40, right, 65. Okay, so you can figure out 65. Well, now look, you got 1.7 across from 65. Excellent. And you have 75 across from all of this distance here, right? This whole distance here. So you could have just used the law of sines in one step, calculated the distance from X to Z. But in this case, we're doing it as two right angle triangles, blah, 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 right? You do the SOHCAHTOA, you end up with the two angles and two sides, and you add them together as 1.8, right? So This is the way you would have done it in the past, right? Break it up into two triangles back in grade 10 when we did this. Now you can actually just use the law of sines. So try it in your own notes there and try law of sines and see if you get the same answer. I guarantee you will. And don't forget units, right? 1.8 meters in the unit. Okay, so that is the law of sines. Next lesson will be law of cosines, which again is along the same line where you have sides and angles of non-right angle triangles. Okay.